in this lesson I'm going to take you through what we mean by surds. So if you have a look at these numbers here, when you square each of these numbers you will get obviously these values over here. So 4 squared is 4 times 4, which is 16. Now if you were to square root any of these numbers here, you will get back to the original number that you had. So if you square root 4, you'd get 2. If you square root 25, you're going to go back to 5, and 5 squared is 25. So these are all reversible. Now what happens, however, if I was to square root the number 3? Now you wouldn't be able to give me a whole number as the answer to the square root of 3, because it's going to be a number between 1 and 2. Square root of 3 would be between the square root of 1 and square root of 4. If I asked you for the square root of 10, you'd be stuck in the same problem. You wouldn't actually have a whole number that you could give me. It'll have to be a number between 3 and 4, because square root of 10 is between the square root of 9 and the square root of 16. And the same goes with the square root of 11, the square root of 20, the square root of 48. You're not going to get me or bring back a number that's going to be a whole number. So all these here that you can see that are none of these numbers are what we call surds. So when we're referring to surds, we are saying that these are irrational numbers. We can't express surds as a fraction, and in fact if you were to type in a surd onto the calculator, so for example the square root of 5, you're going to get something that is an infinite, non-recurring decimal representation of the number, which means that this number actually goes on forever, and there is no pattern. It does not recur. There's no pattern, and it goes on forever. So surds are basically irrational numbers with a square root sign. So any number that you saw before that is not, so if you square root any number that's not a perfect square, none of these numbers here, you're going to get a surd. So we're going to learn to simplify surds today, and these are some of the rules. So if you have a surd or something square root in a bracket with a power on the outside, that power can be applied to just the number on the inside, as you can see here. If you have the square root of a number, you can actually break it down to the factors of those numbers and multiply them. And also if you have a square root of a fraction like this, you can basically square root the top and square root the bottom separately as well. So these are the rules that you need to understand. Now let's have a look at rational versus irrational numbers first. So here, do we have a rational number or not? Well, square root of 25 gives us 5, and 5 can be written as a fraction, okay? Or it can be, the decimal representation of is can terminate or are recurring. So this is terminal. So basically this is a rational number. Over here, 141%, well, we can write 141% as a fraction and as a decimal with no problems, and it terminates, so this is also a rational number. 2 over 3, we can simplify it as 0.66, and in fact the fact that it can be written as a fraction means that it is a rational number, but the square root of 3 is not, it's irrational. Now using these surd rules, let's try and simplify the following. So over here we've got the square root of 20. Now what we can do according to this law over here is we can actually break the 20 up into its factors. So we can go square root of 20 is the same as square root of 4 times 5. Now the reason why I chose 4 times 5 instead of 10 times 2 is because 4 is one of those numbers I can take the square root of. So this can be written as square root of 4 times the square root of 5, and the square root of 4, as we know, is 2, and we just write the square root of 5 there because we can't simplify that anymore. So that is the surd written in its simplest form. Let's have a look at the next one. So we've got 2 out here, and inside we can break it up to, let's do 3 times 100. And the reason why 100 is a good number to have is because we can do the square root of 100. So that will equal to 2 times the square root of 3 times the square root of 100, and the square root of 100 is 10, so that'll be 2 still on the outside times, now because we've made that into the square root of 100 is 10, it'll be 2 times 10, and whack the square root of 3 on it, and that'll be 20 square root 3 as your final answer. That's this in the simplest form. All right, moving on to the next one. So we've got 2 at the top, and the 27 can be broken down into 3 times 9 over 3. And then we've got at the top 2 times the square root of 3 times the square root of 9 all over 3. Now, when you get the hang of it, you can probably skip this step and go straight from there to the next step here. So that will be, oh, running out of room, that'll be 2 times square root of 3 times 3 all over 3. 3 and 3 will cancel out. So you're left with 2 square root 3 as your final answer. Okay, because you can simplify that. Even if you were to multiply 2 and 3 together to get 6 over 3, you should be able to simplify 6 and 3 to 2 and 1. So it's the same thing. All right, over to the next one. Remember, if you square root a fraction like this, you can square root the top on its own, so 125, and the square root of 16. Now we know that the square root of 16 is going to be 4, and the square root of 25 is, you can break it up into 25 times 5, and the square root of 25 is going to be 5 root 5 all over 4, just like that. Okay, now let's do the opposite. Let's bring it back in. Okay, we're going to express these square roots, express these as the square root of a positive integer. So we're just bringing back into it. So how did we get 3? 3 would have been to bring that out, it would have been the square root of 9 times the square root of 2, and so the answer is going to be the square root of 18. Okay, you can think of it as, if you were to bring it back in, it'll be the square. So another way to think of it would be square root of 2, and you bring the 3 in, so that'll be 3 times 3, because it's the square root of 3 times 3 that would have given you 3. So that would be the square root of 18. So you're just doing the opposite up here. And over here is the same thing. So that'll be the square root of 3 times 5 times 5, because you're putting it back into the square root. Okay, that's how it was taken out in the first place. So then you have square root of 3 times 25, which equals to the square root of 75. There, and there you have it.